Welcome to the Solom update for April 1st, 2016. It's April Fool's Day, but there's going to be no fooling around this evening. It's Friday evening. It's about 11:30. I'll go ahead and make this as quick as I can. I do have a lot to cover. I've been busy for the last couple of weeks. I was supposed to go to Albuquerque and install this multimeter down at CFV 2 weeks ago, and that trip was postponed a week, and then that was pushed into this week. The trip this week was postponed, so I found out today that next week is postponed as well. I did not take spring break. I worked every day on this thing, and let's go ahead and show you what's going on. So here it is. Great. Here it is. This is Solom meter number 1. You can see that I got the enclosure all put together. Here's the solar wires coming out. These are MC4, are these 4s or 5s? I don't know. These are solar wire connectors here. There's no ground connection. It's a plastic box. This is totally isolated, so you'll basically pull your string apart, put this in place. It's solar powered. Here's the panel. It's got a LiPo battery. Well, you know the drill there. So this guy here has been running. Not without problems, but I did figure out a lot of things today, and we'll go into that in just a minute. Let's go over to the block diagram, and I'll go ahead and talk about what's now running. In case you need a refresher, I have the current sensor working. I have the voltage sensor working with automatic scaling on both of those. I have the real-time clock working. I got the SD card working this week, so I can read and write FAT file systems on the onboard SD card. That's not removable. It's just meant for a mass storage device on the board. Temperature sensor works. Battery charger works. The LiPo battery works. The voltage regulator works fine. It shuts off at about 2.2 volts. The radio works. I did get a lot of things working with that. I got AP mode and station mode running. We'll talk about that in just a minute. This circuit down here is the temperature sensing circuit, which doesn't exist on this version. Future versions will incorporate this. So this is the shunt resistor up here, and just a refresher, here's your string over here, and it can measure between 0 and 1500 volts from 0 to 20 amps, and it does auto scaling on both the current and the voltage. These are completely independent circuits here, so we'll go into what I found. It turns out that my current the way I did it, I had little problems, but we'll talk about that in just a minute. The current goes this way, which means that the current actually flows this way through the inverter. So this is a floating ground circuit, which means that there is a ground reference in the design, and it's right here, which makes, since the current's flowing this way through the shunt resistor, this is a positive voltage. So everything is ground reference, but all the voltages are positive, so I don't need a negative power supply. This all functions. This all works fine. This theory is gonna work fine. So when one thing I did find this week was the ADD converter. I was not putting it to sleep when I put the microprocessor to sleep. So what that ADD analog front end actually uses about 30 milliamps of current to run the analog circuit. So I actually I now disable that when the device goes to sleep, and now my power draw is down around 2.5 milliamps when it's sleeping. That's still a little high. There's something else going on, but I'll find that out, and I'll figure that out in a little bit. That battery is a 5,000 milliamp hour battery, so that's going to run like 60 days in sleep mode, which is fine for what we're trying to accomplish. Let's go into some of the what was I going to show you? Oh, let's talk about the software. So if you're following along and you want to see the software, it's all in the GitHub repository, github.com/solom. So I have this thing called Baby Steps. These are all the little small programs that I write to test out all the hardware. I try to make them as simple as possible. Now on this particular board, it does have to do, firmware updates are actually very large. So one of the first things I figured out how to do was how to do over the airwave firmware updates. So I created this thing called Basic OTA. This is based on the Arduino library. What Basic OTA does is it just basically connects up and connects to your access point. And at that point, then you can do firmware updates. So all these projects are kind of based on Basic OTA, so I can do firmware updates, and we'll see how that works in a minute. So here's Basic OTA running in the background. I modified it just a little bit to broadcast out UDP packets every second. So this is on my my desktop. I'm running a program that I wrote called UDP Listen, which basically listens on this port, and it broadcasts out this JSON document here every second. This is the board is broadcasting this over UDP. So that just tells you that it's up and running. So some of these other projects in here, ADC0 is the maximum ADC part. AP_STA, I figured out how to make it so that it will switch between AP mode and station mode in the radio. That way you can configure it if it doesn't get connected to your infrastructure access point. I started working on calibration runs here, so this is a cal project. I think I've talked about in the past, actually got a little display going. It's a I2C OLED display. I have a little driver for that. This FS browser project is a thing where you can actually browse the file system on the SD card and edit files on the SD card in your browser and then save them back to the SD card. That's actually pretty cool because you can update like websites and stuff over the airwaves without having to do firmware updates. Here's your basic hello world. This one actually is really a hello world. It just does serial print and it's done. Info prints out the CPU info, like what kind of CPU it is, how much flash it has, those kind of things. I also got the Arduino JSON project running, so I can do both create and parse JSON objects over a socket. PS monitoring is a program that I was measuring the power supply charging and discharging. So PS monitoring actually is doing a little project to do that. RTC reads the real-time clock. SD card actually does read and writes on the SD card file system. Sleep just puts the unit to sleep and it wakes up. SPI is for the A to D. It's basically showing you how to do that. Temperature sensor, and I also have a project where I can do WebSockets. Okay, so this is running Basic OTA. So let's go over and do a firmware update real quick. So over here, I'm going to go to PS monitoring. So if I do a make here, the project's already made. So I'm going to go ahead and push it over to my thing here. I modified the make file, so I can take an IP address and add on the command line. So I'm going to push this firmware update over to the device. You can see that this kind of stopped running up here. It will start again, but it's now going to boot into the power supply monitoring thing. So it's in the process of getting connected now. Once it gets connected, you'll see messages coming up over here. Hopefully. Maybe not. This particular radio module's got some problems with it. Yeah, this one's not going to work. Okay, so, well, it's a demo, so of course we're not going to be running here. Let me just upload it. Oh, there we go. There it came on. Killer. Okay, so it's actually running just fine. So you can see that it runs, it comes up and it broadcasts out about 6 messages and then it goes to sleep. But that's a shutdown thing where it stops broadcasting and accepts a new command. So see if I can do this here. I just missed it. Okay, so now it's going to go to sleep for a minute and then it's going to wake back up again. So I can't do over the airwaves updates when it's sleeping. That's fine. We're all good. All right, let's go back over here. I'm going to switch cameras now, and I'm going to talk a little bit about the grounding issues I found, and then we will come back and in just a minute. All right, I'm over my other lab here, and I'm using my overhead camera. So here's the circuit here. I'm going to go ahead and show you with some stuff that I found. Not too proud of, but we'll go ahead and talk about it. So I followed all the things I know about doing grounding on the circuit board. So what I have is I have a analog ground plane, and then I have a digital ground plane, and there's a single tie point between these two. And then I basically what I end up having is the here's the differential input that goes into that diff amp that actually measures the current sense resistor. So these things go up here like this, and then so this goes, so the current direction is going this way like it is in that drawing. Okay, so these are floating here, and then this is my digital, this is my analog ground right here. This is actually the floating ground for the whole system. So I bring that down and I tie it right here. So then on the voltage side, I have well, unfortunately I didn't draw this very well. All right, here's analog ground over here. So then on the voltage side, I have I got a bunch of FET transistors that are making this funky voltage rate. All right. So here's the PV plus voltage, and this is PV minus. And then I have this arrangement down here where I switch in various resistors and change this voltage divider through these FETs. Okay. And I got about 5 of these FETs, so I can switch them in and out and get this thing to be auto voltage scaling. All right, so what was happening in my circuit was, all right, now these are all connected to ground here, to this analog ground. And everything was working fine until when I started doing a calibration run. What I was seeing was that this sense voltage on this voltage divider right here was changing when this current would go up. And so when I ran up this thing up to about 10 amps, this voltage on a completely unrelated circuit was raising by about 25 millivolts. And that is quite significant. 25 millivolts is really unusable. So I looked at this whole thing for, I don't know, probably 4 hours on a Friday afternoon, and I ended up talking to Crimmins down there at the CFV lab about this, and he told me about the things about the grounding, and I said yes, I followed as much as single point grounding as I could get. Theoretically, this is all fine. I never run any current through my ground plane. The only current is through the sense resistor. I got big connectors, I got those big lugs over here. The only thing that runs through the current runs through here. There's no reason why this voltage here should ever affect the ground plane. And eventually I figured out, well, maybe there's a bridge or something in here. So I cleaned the circuit board real good. I got all the solder flux off. No, that wasn't it. Then what I ended up doing was I ended up taking my voltmeter and I hooked it, to my I hooked my guy here. This is the negative of my DMM. And then what I did was I went through the ground plane and I measured the voltage on all the vias. And they would increase from like 5 millivolts to 25 millivolts. And I figured out the biggest via, the highest voltage via, was way away from the ground plane, which meant that current was flowing through the ground plane, and I also had current flowing in the digital ground plane as well. So I'm pulling my hair out, and I spent about 4 hours on this morning, and I started cutting traces, and I did all sorts of crap. I'll show you an example of that. Here are those two solder lugs that I cut through with an end mill, and the one on the left-hand side is the problem one. Right here, the ground plane was getting connected to the solder lug itself. So I got out my X-Acto knife and I started cutting, and I cut away this ground plane here, and it made it a little bit better, but not really. I still had some issues, so there was another short somewhere, so I cut this one out as well. And it's really difficult to find the shorts because all the resistances are so low everywhere. So then I just started cutting everything. I lifted the ground plane off all these components up here, so I didn't have any possibility of having a shorted connection to the ground plane itself. And I got rid of it. It turns out that left side was introducing about a 40 millivolt signal onto the ground plane, which was lifting it up, like I just previously mentioned. So I still had a really small voltage that was occurring when I was measuring. When I turned the current on, I'd get about a 20th of a millivolt offset in the ground itself. And so it turns out it was where I was connecting my negative lead on my multimeter. I had it connected up to this wire. The black wire I'm connected to does not carry any current, or so I thought. So I really connected it to the right location, which is down here on the board. So if you look underneath here, this is a trace on the board that carries no current now, and all my signal and interdependency went away. So I had not only a board problem, but I had my meter connected up, and those conductors, those wires on the black wire, even though it's not carrying any current, was introducing a very small offset in my measurement. Got that straightened out, and everything started working great. So the board layout's got some problems, but the circuit design is actually sound, so that's a good thing. I'll make some changes to the board layout when I figure out the real connectors I want to use. Then I'll spin that board, and everything will be fine. All right. So this is the reason why 0 is not 0. Yeah, you always just make the assumption that your ground plane is a 0 ohm resistor. It is not. This thing was something very small, but I was pulling a lot of current through it, so I was getting that voltage out. And when you're doing these A to D circuits at 15 or 16 LSBs, 16 bits, you got to pay attention to all that. So after spending about 4 hours this morning looking at the stupid ground plane voltages, I got that thing figured out. Now I'm back to where I was about a week ago. I'm going to start doing calibration runs again. The results I was getting last week were looking great, but I had that interdependency between the current and voltage sense circuits. That is gone. I anticipate I'm going to have really good results based on what I saw last week with my calibration run and getting rid of this dependency that I found today. I'll let you know how that goes. I'm not going to Albuquerque next week, so I will be back on schedule to record my updates, and I'll let you know how it goes. Thanks for watching. Have a good weekend, everyone. This is a Solem update for April 1st, 2016.